bottle of water is put into a refrigerator. The temperature inside the refrigerator remains constant at 3 degrees centigrade. And T minutes after the bottle is placed in the refrigerator, the temperature of the water in the bottle is theta degrees centigrade. The rate of change of the temperature of the water in the bottle is modelled by the differential equation here. By solving the differential equation, show that theta is equal to this, where A is a constant. Given that the temperature of the water in the bottle, when it was put in the refrigerator was 16 degrees centigrade, find the time taken for the temperature of the water in the bottle to fall to 10 degrees centigrade, giving your answer to the nearest minute. Okay, I've got the question summarized here. Okay, we got this differential equation, we need to solve it. So here, separating the variables and integrating. So integral d theta then, move the dt up. We need to move the 1 minus theta down, don't we? The 3 minus theta down. So 1 over 3 minus theta. Integral, so I've moved that down there to be with the d theta. Move the dt up to be with the 1 over 125 dt. And integrating. So there we are. So what have we got then? We've got log of something, 3 minus theta, and then we need a minus 1, don't we? Because it's a function of function. When we differentiate this, log of something goes to 1 over the something, multiplied by the something differentiated, which is a minus. So that would make it a plus. Integrate the right hand side, it's just t over 125. So that tells us now then, if we move the minus over, plus a constant of integration, of course. So ln of 3 minus theta is equal to minus t over 125 plus k dashed. Now unwrap the log, so the base of the logarithm moves over and hits this stuff in the air. So 3 minus theta then is equal to e to the k minus t over 125. So that tells us then, minus is divide, so that would be e to the k over, or times, e to the minus t over 125 k dashed. So we got that. Okay, so I split that up, and then theta. So theta is equal to 3. And then move this over here, so it's minus e to the k dashed times e to the minus t over 125 plus the 3 that's already there. Theta is equal to a e to the minus t over 125 plus 3 is our solution. We've just let a equal minus e to the k dash, that's all, as an arbitrary constant. Okay, minus 0.008, i.e. theta is equal to a e to the minus 0. And 1 over 125 is 0.08 t plus 3. So that's what we've got there, and that's what we needed to show here. Given that initially the bottle temperature is 16 degrees centigrade, find to the nearest minute the time for the temperature to fall to 10 degrees C. So initially equals 0, theta is equal to 16 gives, let's see what we get then, 16 is equal to a e to the minus 1 over 125, t is 0, so this would be e to the 0, and e to the 0 is 1, so we can just write it as a plus 3. And that tells us that a is equal to 16 minus 3, which is 13. So theta is equal to 13 e to the minus 0.008 t plus 3. Theta equals 10 then, because that was the next part of the problem. Find to the nearest minute the time for it to fall to 10 degrees C. Part B. Theta equals 10, gives, so 10 is equal to 13 e to the minus 0.008t plus 3. And that tells us then the e to the minus 0.008t. So it'll be 10 minus 3 is 7. And then move the 13 from here down to divide. So therefore then minus 1 over 125 is what we've got here of t. This is this as a fraction. So take logs, it is equal to natural logarithm of 7/13. So the time then, so that tells us the time is equal to minus 1 over 125. So move this up, move the minus over, ln of 7/13, which equals 125 ln 13 over 7 if we invert the fraction and get rid of the minus. So you can either type in this or this, which equals, now to the nearest minute, 125 times ln of 13 over 7 equals 77.37 minutes. So that would be 77 minutes. And that was to the nearest minute. .77 minutes. And I think that was the question done. Let's just check. 10 degrees C, yeah, that's fine.